All right, so today we're going to be talking about the Krebs cycle, at least the basics of it. So we're going to start off over here by looking at the image from your book. So we start with pyruvate that comes from glycolysis. So we covered glycolysis previously. There are two molecules of pyruvate that are formed. They then are transported into the mitochondria, where they are then broken down to release a carbon dioxide and create something called acetyl-CoA. That acetyl-CoA then enters the Krebs cycle, or the citric acid cycle, where we're going to generate a total of 6 NADHs and 2 FADH2s and 2 ATPs. That's the energy side of things. Then on the flip side of that, as far as the matter goes, we are going to generate 1 CO2 up here, right, and 2 more CO2s down here. Now remind you that there are 2 molecules of pyruvate coming in. So that equates to 2 CO2s here and 4 CO2s here, or a total of 6. And that's our glucose. So our matter is accounted for. So we have energy and we have matter that we're trying to sort of do the accounting for. All right, so let's go and kind of break it down, maybe just a little bit more detail than that. But we're going to start with pyruvate. So here we have pyruvate, and that goes into the mitochondria. So we have the cytoplasm out here, and it goes into the mitochondria in here. So it crosses that barrier. So we're going to draw the double membranes here, right? 2 membranes. All right, so double membrane, and it goes all the way in the inside. And there we go. So now we're going to be in the matrix, and I'll put matrix on here just so we are familiar with that. All right, so we're in the mitochondrial matrix, and it's within the mitochondrial matrix that we are going to release 1 CO2. So at this point we release a CO2 molecule, and then we bind what's left to a big molecule, and you see it over here, big molecule called a coenzyme A. Now you don't need to know that molecule, but at least be aware of maybe what it is. It's just a big molecule, but importantly on one end, it's hard to make out, but we actually have an SH. So remember that sulfhydryl group. That was a functional group. Really important to understand all our functional groups here. So in this particular case, what we're going to do is we're going to actually have acetyl-CoA bound, or acetyl group bound to coenzyme A. So let's look at what that looks like. So we have CH2 bound to a C with an O bound to it, and then that's bound to the sulfur group right here, and the rest of that here. Okay, now that all we're going to write for that is just CoA. All right, so we're going to shorthand the rest of that molecule. So right here we have coenzyme A. Does that make sense? So if you notice, remember, pyruvate had 3 carbons, and we went from 3 carbon down to 2 carbon. That's it. So 1, 2 carbons, right? Here's our 1 carbon and our 2 carbon. And that's going to form our acetyl group bound to coenzyme A. We call that acetyl-CoA. So acetyl-CoA. All right. Next thing you know, we're going to dive into the actual Krebs cycle. So this is actually what we call pyruvate oxidation. Now, we're not actually in the Krebs cycle yet. So let's take this acetyl-CoA and add it to the Krebs cycle. Now, how do we do that? Well, the Krebs cycle is essentially 8 reactions. So we're going to say 8 reactions. I'll abbreviate. REXNS for 8 reactions. And we're going to start with a molecule over here called oxaloacetate. Now you don't need to know its shape or anything like that, but do understand that we have, I'm just going to count the carbons. So we have a 4 carbon molecule, and you don't need to know this, but oxaloacetate. There we go. Acetate. There we go. Okay. So what we're going to do is we're going to combine acetyl-coenzyme A with oxaloacetate. In the process, we remove the CoA. I'm going to put the S on there so we remember that the sulfhydryl group goes with it. So what that means is these 2 carbons and the oxygen and all that, this part here, right? This part here is bound to this 4 carbon. So that means we have a 6 carbon molecule that comes from this. So you're like, what? I thought we were trying to get rid of carbons. Well, we are. So anyway, this molecule here is called citrate. So now we can start to see where citric acid cycle comes. This is called citrate here. Right? So now we have a 6 carbon molecule, and we're going to actually go from here to another molecule called isocitrate. You don't need to know that, but right here, let's keep track of our reactions. I said there were 8 total, right? So there's one where we take and we add our acetyl group to our oxaloacetate, and that gives us something called citrate. Now, mind you, we're not going to learn the rest of them. Just wanted to get us started here. All right, so that's our first reaction. Our second reaction here, right, is going to form something we call isocitrate. Now, nothing really happens there, so we're going to kind of just say, okay, something else happens here. And then we're going to have another enzymatic reaction. And this one is a little bit more important here because a couple of things happen. One, we are going to reduce a molecule, and what we mean by that is, watching the redox reactions, we're going to create an energized NAD molecule. We call that NADH. That's our electron carrier. The other thing we're going to do is remove one of those carbons, so CO2 is released. Okay? So reaction number 3 is pretty important there. All right, reaction 4 is also pretty important, so we're going to go 4 here. We'll put the numbers on the inside, so 4. What we're going to do here is we're going to, again, make or reduce NAD plus to NADH. That's again, our electron carrier, right? And in this particular case, we're going to release another CO2. So guess what? All the molecules left are 4 carbon. We're going to end up back here where we started with oxaloacetate. We've actually removed our CO2. Remember, we started with 2 carbons way up here. Okay, so 2 carbon going into this. We started with 3 carbon pyruvate, 2 carbon acetyl group, and bam, there they are. 1 and 2, they're gone. All right. So now we go ahead and we look at our 5th reaction. It's our 5th reaction that's actually going to be important from an ATP standpoint. So again, this is tied to another molecule called GTP, but we'll kind of ignore that for at least Bio 141. But what we're going to see is that we actually have ADP going in here and then ATP coming out. And that's our reaction number 5. Number 6, what we're going to see is a molecule that's similar to NADH, but it's actually FAD, and FAD is going to be reduced to form FADH2. And again, that's another electron carrier. Okay, finally we have a couple of more reactions, so that is reaction number 6. Then we have reaction number 7. Not a lot happens there, at least for Bio 141 and what we need to know. And then finally we have reaction number 8. And reaction number 8 is going to give us another NADH. All right, so we start with NAD plus and we generate NADH. So now let's try to do some accounting. We're going to go through one time and we'll do some accounting, and then we will say, okay, everything is done twice for 2 pyruvate molecules. So number of ATPs that we generate is equal to 1, right? Per circuit, per round of Krebs cycle, 1 molecule. And the number of NADH is equal to 1, 2, and 3, right? 1, 2, and 3. All right, so 3 molecules there. And then the number of FADH2 from FAD equals 1. So remember, there are 2 pyruvates going into this whole thing. Right? So 2 pyruvates, so 2 rounds of this. So everything gets multiplied by 2 times 2 equals 2 ATP, 6 NAD, and 2 FADH2. This is how much we generate total. So we'll say net or total. Okay. And that is the basics of the Krebs cycle. A little bit more information than we had last time. And we've sort of broken this image down into a little bit more detail. But we get a sense for all the energy that's generated in different forms, the electron carriers and the ATP, as well as sort of tracking the carbons, where those carbons end up. All right, I hope this helps, and watch it over and over again until you really get it, and draw along with me as you watch it. Thank you very much. I'll see you later.